Hi, so today we're going to be solving a problem called sorted squared array. You're asked to write a function that takes in an array of integers that are sorted in ascending order and return an array of squares of the original integers, also sorted in ascending order. So if these were positive integers only, it would be straightforward. So something like 1, 2, 4, 5, 6. The squares will simply be you iterating through the list and returning the square of each number, 1, 4, 16, 25, 36. That's straightforward. It gets tricky when negative numbers are added into the mix. And by that I mean, this becomes 16, 4, 1, 4, 9, 25. Squaring a sorted list of both negative and positive integers results in an unsorted list. And this is where the problem begins. But there is a pattern. The largest square is at one of the extreme ends of the list. And that can help us create an algorithm. So what we simply need to do, now we know where the largest square will be, we can simply iteratively find the least square by moving inward into the list. So we compare for each extreme, the largest square, we record that, and we keep on moving till we get to the middle of the list, which should usually hold the least square. So let's go about solving this question. First, we will need a left and a right pointer. We'll use a left and right pointer at both ends of the list to iteratively find the largest number by comparing each. So we'll say left square, which is going to be minus 4 square, 16 in this case, 5, 25. And we'll compare whichever is the largest. We'll place it in a new list called sorted squares. Now, knowing that sorted squares list is just the square of each integer that was given to us, it will have the same length as the input list. So we can give it arbitrary values of 0, 0, 0, 0, 0, and 0. So once we have our sorted squares, we will take the largest square and place it at the end because we are trying to get our result in ascending order. So we need to place the largest at the end. And to keep track of the slots available from the end of the sorted squares, we need a variable. So we can call it slots. And initially it will be 5 in this case, because this is 0, 1, 2, 3, 4, 5. So it will be 5 in this case. So for every large square we get, we'll keep on placing it at the slot available in the sorted squares list. So let's begin iteratively. First comparison is the left and right here. So we'll say 25 and 16, which is the biggest, it's 25. So we'll place 25 here, 25. And we'll reduce slots by 1. It's going to be 4 now. Slot becomes 4. Then we move the right towards the left. Now the new comparison is going to be 3, which is going to be 9. 16 and 9, which is the biggest, is 16 obviously. So we simply bring 16 to the fourth point, 16, and we reduce slot by 1. Slot becomes 3, and we move the left towards the right. Now the new left is going to be 4. In comparison with the right, 9 is bigger, so we simply make this 9. Reduce slot by 1, slot becomes 2, and we'll move the right towards the left. And the new comparison is going to be 4. Place 4 here. We could move either one, but we could move the left and reduce this by 1. Slot becomes 1 now, so we'll move the left, and now we are the left, and minus 1 squared is going to be 1, so meaning that right becomes the biggest. So simply change this to become 4. Reduce slot by 1, slot becomes 0. Now because right is the biggest, so we moved right towards the left, and now right becomes at the same position as left. Comparison is going to be left and right. They are both equal. So we simply bring the value in here, 1, and slot becomes -1, and obviously it's going to be -1. So we'll stop here, but how do we know to stop here? In our iteration, which is going to be a while loop, we'll make sure that left remains less than or equals to right. Using this condition, we will ensure that the iteration stops at this point and doesn't go further. That's pretty much how we obtain a list of squares in ascending order. So we'll go ahead and solve this problem using a code editor. So the first variable we'll be creating is called sorted squares. This will hold the squares of each integers within the array. And since it's holding just the squares, it's going to be of the same length as the initial array. Now, we also need the first index that will receive the largest square, and we'll call it slot, and it will be at the end of the array. So the length of the array -1. Once we have that, we also want the 2 pointers that would help us find the largest squares as we iterate through the list. And that will be left 0 and right also the end of the array. Now we'll begin our iteration, and our iteration would run for as long as left is not greater than right. That means left remains less than or equal to right. The first thing we want to do during the iteration is to get the left square, and that will be array left squared. We also want to do that for the right. Now we have the left and right square. We want to place the maximum of both of them at the slot position within the sorted squares. So we'll place it at the slot position. Place the maximum between both of them at the slot position. Now once we have done that, we need to decrement slot by 1, because now we have slot position field. We need to get the next slot position that will be available, and that's why we are decrementing by 1. And after doing that, we also need to know which pointer to increase or decrease so we can get closer to the middle of the array. So we can say if the left square is larger than the right square, if the left square is larger or equal to the right square, we can increment the left, and if the right squared is larger, we can decrement the right. So this will help us get closer to the middle of the array, and at the end we return the sorted squares, and this should be it. So we have a good solution here, and I repeat that we created the variable sorted squares first, as well as the first index that will receive the largest square slot. We also created our left and right pointers, left 0 and the right being the end of the array, and we looped as long as left was less than or equal to right, and we found our squares, and we put the maximum of both squares at the sorted squares slot. We decremented the slot, and at the end we checked for which pointer to increase or decrease so we could get closer to the middle of the array. And that's pretty much it.